Alright, let's get started on the next Grind 75 problem. This is problem number 44. Yeah, 44. LeetCode problem 973, k closest points to origin. Given an array of points where points I is equal to x, I, y, I, represents a point on the xy plane with integer k. Return the k closest. There's a fly. I will be right back. Okay, I'm back. That fly is now smooshed. Very, very smooshed. And anyways, let's get back to solving this problem. So, given an array of points where points, you get the point, pun not intended there, and the integer k, return the k closest point to the origin 0, 0. Well, we can, I think the most straightforward approach is a heap slash PriorityQueue of some sort, right? And since this is against 0, 0, the distance formula is a bit easier. Because we can just replace this, and we can just square the x and y, add them, and then take the square root of that. And the reason why we're using a priority queue is because as we insert elements, it is just faster to take the highest, sort of the k number of entries, because it's a sort of I'm not going to say self-sorting, but due to the nature of the heap itself, like the way that you design a heap, that's essentially how it works, that it sort of bubbles up the elements that would be next on the list to take out. There is a corner case here for optimization where you can say if k is equal to point size return points, because it really doesn't matter at that point. It really doesn't matter, because if you have the k number of the k closest points and you only have k points, then oh yeah. Is there actually a restriction that that k is less than, okay, so yes, there is a restriction that is hidden by my webcam, but it says that k is less than or equal to the points dot length, so we can safely assume that this is the maximum case, so at least this will hold if k is at that point. K will never be greater than the number of points, though that would be something to clarify in an interview. So, let's see. I think it makes sense to make a class point where you have a value which is the coordinate, which is equal to an int array. And we can actually put this in the constructor. And then we can say val distance, which is going to be, let's see. Let's assume that it can be a float. And this will be a getter is equal to math.square root. Is that actually a thing? I'll have to check it out. And then it's math.pow coordinate 0.2 double 2.0 plus math.pow coordinate 1.2 double 2.0. So basically what this will do is that this is a distance. This is a distance that is calculated when you call this distance as the getter, because there's no setter in a there is no setter technically in the eval because you set it at the initialization. It's basically equivalent to saying a final variable in Java. And this will just return the square root of the x squared plus the y squared. So Euclidean distance. Technically, we should do -0, but I mean, because it's to the origin, so it doesn't really matter there. So I assume that this will compile, though I could be very much wrong on that. And then we need to build a priority queue, and this is going to be using the Java priority queue, because as far as I recall, Kotlin doesn't actually have its native or a native heap implementation. It natively has a list, a set, and a map. It does not have, and then there are some wrappers, like for example, the IntArray is a wrapper around an array of integers. And similar things for a lot of the other primitives in Kotlin, but there is no heap. So we are going to be using the interrupt functionality of Kotlin to work with Java's priority queue. And that's something that I haven't done before, so I'm going to have to do a little bit of digging into that. So basically the approach is that we will do for each point in points, create a new point in the, let's see, create a new point in the heap, which is where the heap min heap, we're going to be min heap is determined by distance. And basically this coordinate is mainly here so that we can recreate it. Or, let's see, we could also take the reference. We'll also need to create an array of size k, because we've already tackled the corner case beforehand. And then from 0 to k minus 1, basically just go k times. Draw elements from the min heap and add them to the array. And that's pretty much how we will tackle this problem. So this, for each point in points, this will be an O of n operation, because of the fact that we need to go through each point in the points. This is going to be our lower bound because we have to go through all points within the point array in order to figure out which ones are the closest and build our heap. Let's see. Just thinking. This is just going to take O of k operations. And this heapify, actually, when we add it to the heap, this might take O of log n, right? Because at the most, we put it at the top, and then we bubble it down, right? So that will take the height of the tree, or the height of the heap in this case, which is log k, if it's balanced, and it's we're going to be working with probably a binary heap, I assume, under the hood. Maybe it's different, but that's sort of what I assume. So it is probably log of n tall, if my knowledge of data structures is correct. So since this is happening, and this could be the worst case scenario if we have to bury it down to the bottom of the heap every time, then like, what would that be like? That would be like um, if we had a situation where each point gets progressively further from the origin, I think. That would be the situation where we would have this worst case scenario. So therefore, this initial operation, heapify, will take O of n log n, because you have to do this O of log n operation for each point in points. Then we go O of k operations here because, well, when k increases, this increases. We draw elements from the min heap and add them to the array. So in this case, let's say we add it and then we had to bubble down. This removal is in O of, is that removal in constant time? We need to remove an element, but then the bubbling down part, I'm not sure if the bubbling down part actually does also take O of n operations, or O of log n, sorry. So I'm gonna say that it probably does, in some weird case where we need to bubble it all the way down. I don't think that'll be the case for a lot of situations, but actually no, we swap it and then we bubble. Yeah. I'm gonna assume that it takes O of log n then, in that case. So drawing elements will take O of k log n. So total, this will take O of n log n plus O of k log n. And then at this point, it really depends on whether n is greater than k on the full runtime. Though actually, since k is at most n, then it's probably just O of n log n. Since k is at most n, right? At least within the context of this problem. Because you can't draw more elements than there are elements that exist within to build a heap, right? So I think this is pretty straightforward, or I think this is a pretty satisfactory explanation, at least to myself, as to the runtime of this problem. That is O of n log n. Mainly coming from the fact that we have to go through each element, each point, and then we have to add it to the heap, which could be at worst O of log n. So let's actually go ahead and start coding. I think this is a pretty straightforward, pretty satisfactory approach. I'll have to think about whether or not there's a better approach here, but I think at this point, I'm fine with this. The main thing now is really to figure out sort of how to build this priority queue, and that is something that I'll have to do some research on, because I have not used a heap, or I have not used a priority queue in Java before, so this is uncharted territory for me. It's fun. Anyways, let's start by saying if k is equal to points.size, return points. So small optimization there, and then we'll say array, or we need to create a val. We'll call it return array, or closest points, right? Which is of type array of points. Actually, no, it needs to be an array of IntArray. Is equal to array of IntArray of size k, where the initialization is that we create an int array of size 2. I don't know why I always put it into the second line. It's fine to just leave it as a one-liner, I think. So we create an int, or an outer array of size k of type int array, and we initialize it by creating an int array of size 2 for each of them. This might come back to bite me. I'm not sure if this is actually necessary, but we'll go with it for now. for point in points. Actually, no. Why am I doing that style? Points dot for each point. So for each point, we can say we create a new point, and we're gonna need to create that priority queue. So let's take a look at this priority queue initial capacity that orders its elements according to their natural ordering. We can create a comparator. I think this is what we want. So we'll do a val min heap is of type, or we don't need to do that. Priority queue with an initial capacity of k and a comparator. Is there any fancy comparators that we can do? Comparator. Comparator. We'll say this is a comparator. This is an interface. Okay. So we'll say class point comparator or implements comparator override fun compare, and this is of type point, and then this is going to be point A, or A, which is of type point, and B, which is also of type point, and then return. So this comparison, return 0 if the arguments are equal, negative number if the first is less than the second, or positive number. Okay, so when a dot distance is less than b dot distance, -1, a dot distance is equal to b dot distance, which is 0. So a negative number if it's less than the second, right? Okay. And then else we'll return a 1. Okay. And then I think here now we can create a point comparator. I wonder if you have a priority queue. No. Okay. Priority queue. Is priority queue an abstract? Okay, no, it's not. Okay. But I do need to initialize it as of type point, which will take a size of k, and a point comparator, which is a comparator of type point. Right? Okay. And then we can say min heap dot add. We will create a new point which has 0.0, or actually this will just add the point here. It'll create a point that is wrapped in here. So capital P point is our wrapper class that basically just gives it a distance operator. so that we can use a comparator like that. So we add them to the heap. And then for I in 0 to k minus 1, let's see. Now we add them. And then now we want to poll. Is it poll? Really, poll. Logins. Oh, okay, cool. Removes a single instance from this queue. Retrieves and removes. Okay. Okay, so we do want poll. So we want min heap dot poll. And we want our closest points at I is equal to, so we want to basically set this value. And then return closest points. So basically this is our enqueue, or add to heap, right? So we created a point comparator just to compare the distance. So for each, actually, is this priority queue? The head of this queue is the least element. Okay, cool. Yeah, so this is a default by min heap. Awesome, awesome, awesome. So points dot each. So for each point, we we create a wrapper instance of it, and then we add it to our heap. And then for each element, or for each number from 0 to k minus 1, we add it into here. I'm not sure if we can actually override the item. I assume that we can. And then in that case, we might be able to get away with a little bit less space by simply doing, I wonder if we can do empty array. It's empty int array, right? Or something like that. Int array. Empty. Is empty. It's not what we want. Singular, no. I mean, it's a small memory optimization, so it's not a huge deal. Let's start by compiling this and see if there's anything that just goes horribly wrong. Let's see. Infer type is double, but float was expected. Okay, let's just do double then. Comparator t any. Okay, you want a comparator of type point then, I think. Compare overrides nothing. I think this should actually do that. This should actually override compare now. Compare, which returns int. Okay, yeah, it might have been that function declaration actually, because it needs to return an int type. Unresolved should be, this should be visible, right? Should be visible. Not conform to the type. Yeah, that's fine. Unresolved. Point comparator does not have a companion object and thus must be initialized here. That is fine, right? Yeah, we just create a new instance of that point comparator. Actually, we could do a companion object. Can we do a companion object here? You know what, I'm not going to worry too much about the companion object stuff until I get this actually solved. Min heap.poll .coordinate. There you go. Okay, let's see if there's any more errors that we come up with. We're still getting an unresolved reference to distance, but this is of type point. Unless this doesn't count as a field that we can actually, or unless this doesn't actually count as a field that we can grab, which doesn't make sense. Why can't we grab that field? Not value. Getters? Or field? Getters and setters. Do I need to do this dot coordinate and this dot coordinate? But why can't I do this? And yeah, I guess that can be inferred. So val distance get is equal to that. But, let's see. We should be able to get it. Backing field if it uses the default implementation. I don't think we need a backing property. I'm really not sure why this is not getting it. Did I misspell distance? No, distance is correct. Unresolved reference still. This is a class of type point. Let me see if I do val a distance is equal to, just do that, a will this error on me? It really doesn't like this. It is not even letting me grab the coordinate. Why is that? I don't think this class needs to be outside of the solution. Yeah, no, that's not it. I wonder why it's not grabbing that information. I don't think that point is a reserved name for anything else. I'm really confused. Not sure why this is going wrong. Can I create a companion object then? Maybe that's... The companion object can implement interfaces. Comparator extends comparator point comparator. And then we just override that function. Tab things out a little bit. Do I need to add this here? Type parameters are not allowed for objects. Is it fine if I do a generic type though? And this can be renamed to point.pointComparator, right? Since this is just a companion object. Oh no, companion, oh, okay. Okay then. Yeah, that's really weird. I'm not sure why initially it just didn't work. Like outside. That is something that I'll have to take a look at. That's just straight up like Kotlin knowledge not being enough. Um, okay. So ran through the test cases fine. And honestly, I'm just gonna toss it through the submit and let's see what happens. Maybe this is just too slow, but otherwise it's just a sort of introduction to heaps, which I'm fine with. Okay, so the runtime is faster than half, so it's about average, and the memory usage is pretty good. So I'd say that this is probably a pretty standard solution, and I'm fine with leaving this here. This was a very fast problem, surprisingly, but I mean, it's a pretty straightforward problem. I'm happy that this is sort of my introduction back into heaps, because I have not used heaps in quite some time, and I need some time to sort of get familiar with them and sort of like think about like, okay, inserting it, how fast will it take, removing, how fast will it take, and then just sort of the process of like creating a comparator to add it into here. But overall, this is a really nice solution, I think, because it's just really short. I like it. I just love how concise Kotlin can be sometimes, even though I have no idea what happened here with the comparator. But in any case, I hope you learned something with the heaps and the k closest points, and I'll see you for the next problem.